So we're in section 5.5. We're talking about area of regular polygons. And let's remember what we mean when we say a polygon is regular. So when we say our polygon is regular, what are we saying? This part, no. We're just kind of getting started here. What do we know about the sides of a regular polygon?
Same.
They're all the same length. And if all the sides are the same, what do we know about all the angles? They're also all the same. So what we're talking about here is a polygon that has all the same side lengths and all the same angles. So we can use these formulas for any polygon. It could be a triangle, it could be a square, it could be a pentagon, hexagon. As long as they have the same side lengths, we can use what we're talking about today. Doesn't matter what the polygon is, as long as they have the same side lengths. So in your flip book, you have a couple of drawings. I'm just going to label one, but I would suggest that you label both of the polygons that you have in your flip book. So I'll draw a pentagon, and I'm going to try to get it to look regular. So that's close. And the point here is our center. And we have two segments drawn in, and we're going to label those. So let me draw those in. We have this one. And I'm going to do the other one in a different color. We have this one. And this is going to be a 90-degree angle. This segment is the radius. The radius goes from the center to a vertex. The red segment is called the apothem. And the apothem goes from the center to the middle of a side. And the apothem makes a 90-degree angle with the side. So we go from the center to the middle of a side at a 90-degree angle, and that's our apothem. The radius goes from a center to a vertex. It's really important not to confuse those two, because if you do, your calculations will not work out the right way. Now we could keep drawing segments for the radius around our polygon, and we would have triangles that were all the same size all the way around. Because it's a regular polygon, all of our triangles would be the same size. We could find the area of the polygon by adding up the area of all the triangles. And that's where our formula comes from, is if we divide this into triangles and add up the area of all the triangles inside the polygon, that would give us the area of the entire thing. And that's how we come up with our formula for the area. So let's write our formula. We need one other piece of information for our formula. Our area equals 1/2 the apothem times the perimeter. if we say that the way we normally write it is the apothem is A, and the perimeter is P, so we can write this as the area equals 1/2 AP, and that's the same as AP divided by 2. So we're multiplying the apothem times the perimeter. And for any polygon, how do we find the perimeter? What do we do to find the perimeter? What is it? We add up all the sides. So we don't use a special formula to find our perimeter, we just add up all the sides. So this is our formula for the area of a regular polygon. 1/2 the apothem times the perimeter, or the apothem times the perimeter divided by 2. It looks a lot like the formula for the area of a triangle, because that's where it comes from, is we add up the area of all these triangles inside our polygon. And we have to be careful that we're using the apothem, not the radius. And we'll do an example where we have the radius and we have to figure out the apothem. There's a way that we can do it that we already know how to do. So any questions on our formula? All right, let's look at a couple of examples.
Need to copy that.
You need to go back?
Yeah.
Okay. Good? All right. So a couple of examples with a regular polygon. The first one, we'll use a pentagon again. And if my drawing doesn't look like it, we're going to say that this is a regular pentagon. And here's our center. And I'm going to draw in this segment. And we're going to say that this is 8 centimeters. And this is 12 centimeters. And we want the area. So what two pieces of information do we need to find our area? The apothem and the perimeter. So the apothem equals what? 8, 4, 16. The apothem is the distance from the center to the side. So you're thinking, you were plugging it into the formula already when you said 4. So we're just looking at the length of the apothem. So our apothem is 8 centimeters. It goes from the center to the side at a 90-degree angle. The perimeter of this shape. The perimeter, someone said 60, and how do we come up with 60?
12 times 5.
12 times 5. So we just add up all the sides. We have 5 of them. They're each 12 centimeters. So my area is 1/2 8 times 60. And there's our 4. 1/2 of 8 is 4. And when we multiply this out, we get 240. And our units? Centimeters squared. We're talking about area, so our units are going to be squared. So the area of this pentagon is 240 centimeters squared. So this one was nice because we could just plug in to our formula. And now remember that when we're on some of the problems that we work, maybe not today, but We can also, if we're given an area, we can solve the equation going the other direction and find the length of the apothem. So using what we know about algebra, we can use the equation going either way. We can find the area or we could find the apothem. Questions on that example? All right, let's look at one where we have the radius rather than the apothem and see what we have to do with that. So here's our shape. Let's draw in that length. And let's say that is 5 inches and the side length is 6 inches. And we want to find the area. And this, we're going to say this is a regular pentagon. So to find our area, we need the apothem and the perimeter. But we don't have the apothem, we have the radius. The radius is 5 inches. Anybody have an idea of how we're going to find the apothem from this? Tim?
You could do 6 divided by 2, which is 3, and then multiply that by square root of 3.
So that, we'll talk about that one in just a second. With a pentagon, that one won't work because our angles don't work out the right way. We'll talk about when it does work.
We need to borrow you for a second, Mr. Beamer.
I can't do it right now.
Just a quick picture. It's like 4 seconds. Ready?
So this is a pinhole camera.
It is. Thanks.
The face that he makes is part of the deal. All right. Let me draw in the apothem. There's my apothem. What does this red segment do to the side, this side of the pentagon? Cuts it in half. So this little bit is 3. I have a right triangle here, and I have, for a pentagon, it's not a 30, 60, 90. We'll talk about the shape when it is. But I have 2 sides of the right triangle, so what always works on a right triangle? A squared plus b squared equals c squared, or the Pythagorean theorem. Which side is c in this triangle? Which side is the hypotenuse? 5. So this is c. So I'm just going to call this a. It's side a of the triangle, and it's also our apothem. So I'm going to say a squared plus 3 squared equals 5 squared. Anybody know what it's going to come out to? Comes out to 4. 3, 4, 5. I reminded you the other day, 3, 4, 5 comes up a lot. So we take the square root of both sides. I subtracted 9. So a equals 4. So my apothem is 4. So when I have the radius, when you have the radius of your regular polygon, you have to use the Pythagorean theorem to find the apothem. And you draw in your apothem to get a right triangle and use the Pythagorean theorem. So my apothem equals 4. Now I need the perimeter. What's the perimeter of this shape? 30 is 5 times 6. So my perimeter is, I'm going to put my units in, inches. 30 inches. So my area, finally, is 1/2 the apothem, which is 4, times 30, which comes out to 60 inches squared. So when I have my radius, I can use the Pythagorean theorem to find the apothem. Questions on that one? All right. And Tim was kind of helping us out as we move ahead. There's one kind of polygon where we can use another thing that we know to find the area. So let's look at that. And I like to say, to help us remember, hexagons are special. Hexagons are a special kind of shape because we can find the area only knowing one piece of information. So let's draw up a hexagon and see why that works out that way. So here's my hexagon. I'm going to make it nice and big so we can label it. And we're going to say this is a regular hexagon. And I'm going to draw in a couple of segments for the radius. So now I have a triangle down here. Does anybody remember how we find the central angle of a polygon? Anybody have a guess?
Oh, it's the thing that has 2 on it. 2 in the formula.
You're thinking of the interior angle. We'll need that one in just a minute. This one's easier. We have 6 sides.
Don't you add 2 to the number of sides, multiply that by 180, divide by 6?
You're thinking of interior angle also. So the interior angle is this angle, and we'll talk about that one in just a second. I'm looking for this angle.
Looks more.
This one is interior, this one is central. To find the central angle of a polygon, we divide 360 by the number of sides. So 360 divided by 6 is
36.
60. There we go. So that angle is going to be 60. And Jalen helped us out with the formula for our interior angle. So our interior angle is n minus 2, the number of sides minus 2, times 180, divided by n. So you remember the more complicated formula. Here n is 6 because we have 6 sides. So I do 6 minus 2 is 4 times 180, divided by 6. And if I multiply that out, that comes out to 120 degrees. So this angle is 120 degrees. What does the radius, this segment that makes a radius, do to this 120 degree angle? Cuts it in half. So this angle is going to be 60 degrees also. I'm going to write that in a little smaller. If I draw in my apothem, what is my apothem going to do to this 60 degree angle? It's going to cut that one in half. So let me erase this. And I'm going to draw in my apothem in blue. So there's my apothem. There's a 90 degree angle. And this angle is 30 degrees. What kind of triangle do I have here? A 30, 60, 90. If this is the side length, how long is this little piece? What does the blue segment do to the side? Cuts it in half. So this is the side. divided by 2, or half the side. On my 30, 60, 90 triangle, is this the short side, the long side, or the hypotenuse? That's the short side. This, the apothem, is that the short side, the long side, or the hypotenuse? Long side. How do I go from the short side to the long side? Multiply by square root of 3. Very nice. So the apothem of a regular polygon equals 1/2 the side times the square root of 3. And the perimeter is just 6 times the side. So the perimeter is just 6 times the side. So all I need to find the area of a regular hexagon is the length of the side. I don't need any other information because the apothem divides, if I draw in the radius in the apothem, it divides the regular hexagon into a 30, 60, 90 triangle. So I have another area formula that's just for hexagons. So for regular hexagons, and this is why they're special, and this is for regular hexagons only. It doesn't work with any other shape. The area I'm going to say the apothem first. The apothem equals 1/2 the side times the square root of 3. And then we can use this apothem times the perimeter to find our area. So all we need to know to find the area of a regular hexagon is the side length. From that we can figure out the apothem, and we can figure out the perimeter just by adding up all the sides, and we can find the area. So for regular hexagons only, all we need to find the area is the side length. Any questions? All right, let's look at an example of a regular hexagon. So here's our hexagon. And we're going to say it's a regular hexagon. And we'll draw in our, we know that the side length is 10 inches. And the apothem, we'll draw in our apothem here. Here's our apothem. We have a regular hexagon. So the apothem is half the side length times the square root of 3. So the apothem equals 1/2 of 10 times the square root of 3. And that gives us 5 square root 3. And we're in inches. The perimeter. How do we find the perimeter of this hexagon? What's the perimeter? 10 times 6. So our perimeter is 60 inches. So I have my apothem. I have my perimeter. So the area is 1/2 the apothem, 5 square root 3 times 60. And this is the same as, I can rearrange this. This is the same as 1/2 of 60 times 5 square root 3. When I multiply it, the order doesn't matter. So this is 30 times 5 square root 3. And finally I get that my area is 150 square root of 3 inches squared. All I needed to know because I had a regular hexagon, and hexagons are special, that all I needed to know was the side length. I can figure out the apothem and use that to find my area. Any questions on that? Okay. We'll go over last night's homework.